go to example 3 in your notes, and we're going to factor this polynomial. As you can see, there's 1, 2, 3, 4 terms here. Whenever there's 4 terms in your polynomial, we try to think, can we factor by grouping? So if you group the first 2 together and then group the second 2 terms together, we can try to factor the GCF out. So the GCF of the first 2 is going to be z squared. And then I'm left with what? Z plus 5. From the second group, I want to take out a negative 4 so that I have the same thing left over. So what's left over? Z plus 5. So now that you can see z plus 5 and z plus 5 match, we can factor this into 2 groups and say z squared minus 4 and z plus 5. And you would be done unless you could factor further. And I know z squared minus 4 factors into z plus 2 and z minus 2. And then we have z plus 5. So that's going to be my final answer for example 3. Then taking a look at example 4, I want to factor polynomials in quadratic form. So looking at part A, I know that I have perfect squares here. 16, x to the 4th, and 81, they're all perfect squares. So I can rewrite that and say, what's the square root of 16x to the 4th? Well, it would be 4x squared to the second power. And then the square root of 81 is 9. So if I rewrite it this way, then I'm able to factor just like a squared minus b squared equals a plus b times a minus b. So once we find a and b, which in this case my a is 4x squared, my b is 9, we can factor this to get 4x plus 9 and 4x minus 9. And I forgot the squareds here, so I want to say 4x squared for both of these. I forgot to put that in. So from here, again, we have to say, can I factor any further? And 4x squared minus 9, that's another perfect square. 4 and 9 are perfect squares, so we can factor that again. So I'm going to get 4x squared plus 9, and then I'll factor 4x squared minus 9 to be 2x plus 3 and 2x minus 3. So there's the answer written nicely. For part B, I'm looking at this and I see 3 terms and I see a lot of variables and high exponents. Is there a GCF that I can take out? So I can see my GCF is going to be 3p squared. And once I take that out, divide everything in this in part B, in this polynomial, by 3p squared. So when I do that, I'm left with p to the 6th plus 5p to the 3rd plus 6. Now I have to figure out, can I factor this second polynomial that I just came up with? And the answer is yes, I can. From the last video, you got the definition of quadratic form, and that's going to help us to factor this. So I have 3p squared on the outside still. That doesn't change. And then p to the 6th plus 5p to the 3rd plus 6. I think to myself, what 2 numbers multiply to 6 and add to 5? So that would be 3 and 2. And instead of like normal, where we would do p plus 3 and p plus 2, we're going to do p to the 3rd plus 3 and p to the 3rd plus 2. Because our first term, we want to get p to the 6th power. So I know 3 plus 3 adds to 6. And then we want to get p to the 3rd in the middle, and that's how we'll get that. So this would be my final factored answer.